Hello everyone, you are watching video notes 9.3, Interpreting Univariate Data, which means one variable data. One variable. Exercise 1. A local marketing company did a survey of 30 households to determine how many devices the household contained that family members watched video on. So like TVs and tablets and smartphones. The data is shown in the table below. Here's the number of devices, and here's the number of households. The variable that we're talking about is the number of devices, and the number of households then would be the frequency, how many times it occurs. So there's one variable and then a frequency counter. The total on this column should be 30 because there were 30 people in the survey, 30 households in the survey. The data is modeled in 3 different ways. So you have a dot plot, you have a box and whiskers plot, and you have a histogram, and a bunch of questions that we need to answer. Answer the following questions based on the data. Find the median using all 3 graphs. All right, so on the dot plot, the median, if you have 30 items and you split that in half, you're looking for the 15th data value to get to the middle, because median means middle. So I'm going to count dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it looks like the middle is around here somewhere, right? 15 over here, and there should be 15 dots over there. So my median falls between the 3 pile of dots and the 4 pile of dots. Looks like it's 3.5. Let's check it out on the other graphs. The median on a box plot is right here between the 2 boxes. Median. So that's easy to see. It's still 3.5, right again. On a histogram, let's see. Well, median, we're going to have to look at the frequency, the height of each bar. This one goes up to 7, this one goes up to 8, this one goes up to, looks like 11, this one goes up to 2, and then 1, and then 1. So again, our magic number is the 15th data value. Counting from the left, that falls right here. We got 7 plus 8, that's 15 over here. And then 11, 2, 1, and 1 is 15 over here. Again, the median is here between the 3 and the 4, so I agree with 3.5. Which graph was easiest to find? I would definitely have to say that was the box plot. There's a line right there for you, right between the 2 boxes. How many households have 3 screens in that household? All right, so I'm going to use my red pen to answer this question. 3 would be 3 dots on a dot plot, so there's 3. Oh, no, wait a minute, I'm lying. Number of households, 3 devices. Okay, never mind, I did that wrong. That's not what I want. I want to know where 3 screens is. Down here is the number of devices, otherwise known as screens. So 3 screens, and the dots count the number of households. 1, 2, 3, 4, 5. Let's see if I can find that on each picture. 3, 3. I can't really tell how many are in there. And on here, well, I can tell that 2 to 3 devices, there's 8, but I can't really tell, again, devices is screens. I can't really tell how many have 3. It includes everything from 2 and 3. So if you look at the dot plot, these total 8, and that's why this bar goes up to 8. But the correct answer is 5, and I had to use the dot plot. How many households have 5 or less screens? Okay, 5 or less. Well, on the dot plot, here's 5. So here is 5 or less. So if there's 30 altogether, I'm going to count the lesser dots. 1, 2, 3, 4. 30 take away 4. There must be 26 in this blue box. 26. On the dot plot, 5 or fewer. Let's see, can I tell? Well, sort of. I know that each of these areas that I'm circling right now, or I'm trying to anyways, in blue, is a quarter of the data. So 3/4 of the 30 data values fell below 5. So if I take 3/4 of 30, let's see, 3/4 of 30, 90 divided by 4. Okay, that's 22.5, but this value was my upper quartile or quartile 3 value. It might not have been actually a data value. It could have been rounded to find that number between two numbers. So that's not very good to tell with. The histogram is not too bad. If you add up 7 plus 8 plus 11, because that takes us to the end of the 5s, right? 5 or fewer would be 7 plus 8 plus 11. Yep, it's 26 again. The easiest graph to use, I would say, would be the dot plot, or you can use the histogram. So you can clearly see, if you look back at those answers, that some graphs show things better than others. Box plot, dot plot, histogram, all were used at different times. Okay, on the next page, we're going to talk about skewed versus symmetrical data plots. So we're looking at dot plots, and if you notice that the tail is off to the right, then that happens to be skewed right. Symmetric, they sometimes call this a bell curve, perfectly symmetrical from left to right, with average somewhere in the middle, or right in the middle. Skewed left would be a tail going off to the left. So it's which way the tail goes. Whatever way the tail goes is where you call it skewed. Okay, exercise 2, given the data to the right, explain if the data is skewed left, right, or symmetrical. Well, it's definitely not a perfect bell-shaped symmetrical. I see a tail going to the right, so tail goes to the right, which means the data kind of falls off at that end of the graph, and the distribution is skewed right. There's less data at that end of the graph. Exercise 3. Corinne is planning a beach vacation in July and analyzing the daily high temperatures for her potential destination. She'd like to choose a destination with a high median and a small interquartile range. So she made these box plots in the diagrams below. She's got Ocean Beach, Whispering Palms, Serene Shores, and Pelican Beach, all plotted on scales. Which destination has a median temperature above 80 and the smallest interquartile range? Median temperature above 80. I'm looking at these middle numbers here. Nope, not Ocean Beach. So it could be Whispering Palms. That median falls above 80. Serene Shores. Nope, not Serene Shores. Could be Pelican Beach, falls above 80. But which of those has the smallest interquartile range? Well, interquartile range is from the end of the box to the end of the box, beginning to end. This is definitely more of a interquartile range than Pelican Beach. So the smallest one would be Pelican Beach. So remember, IQR takes you from one edge of the box to the other, because this would be Q1 and this would be Q3, and it's Q3 minus Q1. Exercise 4. A sociologist chose 300 students at random from each of two schools and asked each student how many siblings he or she has. The result is shown in the table. What's the median number of siblings for all the students surveyed? So since there were 300 students from each of two schools, basically we're looking 300 from each. We're looking at this total is 300 and this total is 300. So the middle of the data would be about 150 for this list, would fall somewhere in these 80. If I start counting from the bottom, try to get to 150, I end here. Or from the top to the bottom, still this way also, I end here. 150 for this list would also end here. And if you count up, 150 will be in that group also. So it's looking like the median number of siblings is going to be 1. If you considered it out of 600, you'd be looking for the 300th data value. So overall, you would still be falling in this area for the 300th data value if you did it total. Okay, that concludes looking at data on our graphs, so get to work on practice.